If you worked with Kubernetes, you may have seen a situation like this. Multiple YAML files, all creating different resources within your Kubernetes cluster. While this can work for one-off deployments, it isn't necessarily going to be an easily repeatable pattern, and that can cause issues. Today, we're going to be taking a look at how Helm can relieve this issue, and we're also going to be looking at how we can use Helm to install third-party apps. So what is Helm? Helm is a template engine and package management tool for Kubernetes. It allows users to build reusable YAML templates that can be packaged and distributed. So let's take a look at the file and folder structure. So here we have our chart.yaml. In chart.yaml, we have the API version, which is a versioning system within Helm to specify how the chart's supposed to be structured and dependencies are set up and referenced and managed. Then we have the name of the chart, the description, the type. We're going to be making a chart of type application, the chart version specified as version here, and the application version. The application version will be used to specify which app version this chart's deploying, and the version is going to be saying which version of the chart are we working with. Let's take a quick note. Chart.yaml needs to be named chart.yaml. Values.yaml should be named values.yaml when you're creating a chart so that Helm can find it as its default set of values. Templates needs to be called templates, all lowercase for the folder name. And charts is where dependency charts are stashed. That folder is generally managed by Helm. Let's go into templates. And we see we have underscore helpers.tpl will contain templates that can be reused within deployment and sa.yaml. And deployment and sa.yaml will contain the partially templated YAML that will actually create output. Let's check out deployment. If you're familiar with deployments, the structure will make sense. If not, check out this video here. The new piece are these curly braces. The curly braces are what activates the Go templating engine. We can then use the space inside to be able to make value references to the values file. Here, we see the reference structure clearly. On the left, we have .values.appname within the curly braces. On the right, in our values file, we have appname and the values applied. Now, we see that we have this dash over here. This is for eating up white space. When the template is rendered into YAML, sometimes there could be extra white space on either the left or the right side of the argument. In this case, it'll remove some of that white space. Here, we have the pipe, which will take .values.labels, grab those values being passed in, and pipe them over to YAML. Think of this pipe as you think of the pipe operator in the shell or bash. To YAML, we'll convert it to YAML in the output, and then piping that into an indent, we'll do a new line and then indent the block by the specified number of units. Then let's make note of range. What range is doing over here is iterating through the array that we passed in. Here we have a YAML array under container config, and then we can conveniently reference the arguments of the array entries directly. So .name, .image, .command, .args, and so on. And we see the same technique applied to .env over here. Next, let's take a look at service count. Here we have our conditional operator, if values.createSA, which in this case is checking if this value is defined. If it is, then it'll create a service count. If not, it won't. Finally, let's take a look at helpers. Over here, we can define our helper template function. So it'll take in the current context as an argument, and once done, it'll check if values.createSA is true. If so, it'll print an output variable, which corresponds to name. If not, it'll use the current service account that's been passed. And we can see this play out in our template over here, where we say include SA, and then we pass in dot for the current context. Let's install our application. Make a reference to the context. There's our values file. We've installed it. We can check out the pods running there. Next, how do we update? Well, go right over here, take the value, save it, and get a preview of what our change will look like. There we see it's going from 3 down to 2, so let's run it. We see that our pods are scaling down to 2. Now, let's do the following. We're going to do another update. And we'll run a bad update. Same command as before. Run our diff. We see the bad update. And let's run an upgrade again. Now we see that we have this error. It's a problem. So here's a way to quickly recover with Helm rollback. We're going to use Helm rollback to go to the last revision of this release, but you can also specify a certain release number. If you want to see a specific revision, we can do this. Helm history test. And there we can see our release history with the revisions in it. But we're just going to roll back to 2. And there we go. We rolled back to our last functioning revision where we had 2 pods. So how do we uninstall a chart? We do the following. Uninstall, and we put our release name. Now it's uninstalled. And we see our pods terminating. Let's install a third-party application using Helm. Helm is not only a templating engine, it's also a powerful package management tool as well within Kubernetes. It's one of the most common tools you'll use to install third-party applications within your cluster. So, for example, we're going to be installing an Ingress controller into the cluster today from HA Proxy. And here, we're adding the repository as well as a link to the GitHub repository. We see that it's been added. We can then inspect the repositories we have locally by running Helm repo list. And here we see we have a few other ones installed, but namely, we see that we have HA Proxy added on the bottom. Before we install the chart, how do we see which versions are available? We can see the versions of the packages that are published to the repository using the following command. We now see we have 3 different charts we could potentially use. The one we're going to be looking at is the Kubernetes Ingress one. Now, how can we see the different versions that are published for the Kubernetes Ingress chart? We then pass the versions flag. And now we see every version that's been published. The one caveat being that some versions, depending on how old they are, could be pulled from the registry. But depending on the maintainer, many versions are kept. We're going to be installing the latest version of the chart, 1.52.0. Another thing to note here, as we saw from our chart.yaml, chart version, the app version, which is the actual application versions running within the chart, as well as the description and the name. We install the chart using the same command that we used before to install our own local chart with some variation. And here we have our command. Let's run it. It's been installed. And we now see our Ingress pods are booting up. So we installed our application, but how do we know what values we just passed? We can grab them using the following. And there we go. You can dump this to an output file, values.yaml. And now we can see all the values that have been passed to the chart by default. From here, we can update these values and then redeploy the controller. Let's bump the replica count. Let's run the following. The diff will be larger here since there are more assets, but we can see our replicas have been updated. So let's deploy. And there we go. We can see that we now have 3 replicas. And if we wish to uninstall our application, we can do the following. Helm list, uninstall, proxy, ingress. And we see it's being removed. Thank you for your time. If you like the content in this video, drop a like. If you enjoyed and want to see more, please subscribe.